Hello students, welcome back. In this module, we are continuing with the problems based on the continuity in an interval. Moving ahead with the problem, what does it say? You need to find alpha and beta for a function where in the f of x is minus 2 into sine x for minus pi to minus pi by 2, alpha sine x plus beta for minus pi by 2 to plus pi by 2, and cos x for pi by 2 to pi is continuous on minus pi to pi. So you have a range with you that is minus pi to pi. It is continuous at which point x equal to minus pi by 2. So I can say limit x is tending towards pi by 2 minus f of x should be equal to limit x is tending towards pi by 2 plus f of x. So in this case, equating with both equations, what the equations are? For pi by 2 minus, it is the minus 2 into sine x, and for pi by 2 plus, equation is alpha sine x plus beta. So we know it is continuous at minus pi by 2. So substitute x as minus pi by 2. So equations would be minus 2 into sine of minus pi by 2, which is equal to alpha into sine of minus pi by 2 plus beta. We know sine of minus theta is minus sine theta. Therefore, sine of minus pi by 2 would be minus sine of pi by 2, and hence it is minus 1. So in this case, minus 2 into minus 1 would be equal to alpha into minus 1 plus beta. Therefore, minus alpha plus beta would be equal to 2, and it's equation number 1. As function is continuous in that whole range, also it is continuous at pi by 2. Therefore, limit x is tending towards pi by 2 minus f of x should be equal to x is tending towards pi by 2 plus f of x. In this case, for pi by 2 minus, the equation is alpha sine x plus beta, and for pi by 2 plus, the equation is cos x. In this case, substitute x as pi by 2. Therefore, the equations would be what? Alpha into sine of pi by 2 plus beta, which is equal to cos of pi by 2. We know sine of pi by 2 is 1. Therefore, alpha into 1 would be alpha. We also know plus beta, which is equal to cos of pi by 2. Cos pi by 2 is 0. So, alpha plus beta is 0. Hence, I can say equation number 2. Now, solving both the equations 1 and 2 simultaneously, what we get? We know alpha plus beta is 0, and we also know minus alpha plus beta is 2. So by adding them, you would get 2 beta as 2, and from this I get the value of beta as 1. We also know if alpha plus 1 is 0, then alpha would be minus 1. So in this case, the values of alpha and beta are alpha is minus 1 and beta is plus 1. Moving ahead with the next problem, you need to test the continuity of a function f of x, which is given by x plus 1 the whole upon x minus 2 into x minus 5 in the respective intervals of 0 to 1 and 4 to 6. So here f of x is an rational algebraic function, yes, and hence it has to be continuous for all the values of x in the range 0 to 1, except at those points where denominator is 0. Students, such statements are very important. So I can say x minus 2 into x minus 5 is equal to 0. That is, I get the values of x as x is equal to 2 or x is equal to 5. Now, for case 1 in 0 to 1 range, this x, that is 2 and 5, they both are out of range. So I can say x as 2 and 5 does not belong to 0, 1. Therefore, I can say f of x is continuous in that complete range of 0 to 1. Moving ahead with the case 2, we have the values of x as 2 and 5, and over here the range is 4 to 6. In this 4 to 6, 2 is out of the range. So I can say 2 does not belong to 4, 6. Therefore, x is equal to 5 is a point of discontinuity in 4, 6. Hence I can say the function is continuous in 4, 6 except at x equal to 5. See you in the next module. Thank you.